Hey everybody, this is Larry. This is day 12 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. I'm on day 2 of my fast, so everything looks like food right now. If I could see you, I would probably try to eat you, so I'm trying to... I don't know what I'm talking about. You don't need to know this. Okay, but... Anyway, today's problem is 63 unique paths to. Okay, so you're given them. You have given a grid. You're upper left. You could go to bottom right. You can only go down and or right. Okay, and there's some obstacles. Otherwise, it's just n plus m choose n or something like this. Give or take 1 or something. I don't know. And you don't have to worry about overflowing. Okay, I mean this is very straightforward. In the sense that, you know, it is something that I think we talked about. Was that like yesterday or the day? Oh no, I think we did. I did a similar problem on Codeforce like a couple of days ago. So I think I'm just mixing things up together. Never mind that. But it's still not that difficult. I think the one thing to kind of keep in mind, and you know, it doesn't matter for this problem, but or maybe you know, I just want to point it out as an observation that you know, you might be doing this without realizing it, and then when you get to a more difficult dynamic programming problem, if you're doing the same thing, that's not going to be good, right? So that's what I want to point out. And for this problem, and I kind of point this out actually relatively more frequent nowadays, is that I'm very hungry. But also, but also that this problem, the DP is symmetric in a way, right? And what I mean by that is that the number of paths to go from the top left to the bottom right is the same number as the number of paths going from the bottom right to the top left. So why do I say that? And I think even maybe the other directions, but that's just even more ridiculous symmetry stuff. I say this because this is not always true for every problem. I mean, it's always true for this problem, but it's not always true for every problem. And because of that, you have to be very careful about how you write your code for those problems. And you know, you could start by doing it with this one. And kind of with that in mind, then like the ordering matters and stuff like this. Here, you can kind of go forward, you could go backwards, you could push, you can pull, you can do a lot of different things, and it'll actually be right because of symmetry. And symmetry is one of those things that you don't realize you have. And maybe it's just me also, because I like to point it out because it took me, honestly, probably took me a year before I realized why I struggled with certain dynamic programming problems and not others. Like I'm like, oh wait, why is this particular one harder than the others? And I just couldn't figure it out when I was a beginner, right? And this is decades ago. And you know, the literature isn't as, you know, as you know, the literature is just not as widely available back then, say. But yeah, so basically what is an example of this, right? And maybe we'll get in a couple of days or whatever. But an example of this is it's something that is not reversible, right? Like a function, like maybe you have to get a min or a max, or you know, maybe if there's an if statement in there somewhere, meaning like, you know, if like I think there's one with like health points, and if the health goes below 0, well that's not symmetric, or you have to define it differently to get certain things, right? So I just want that to be precise, meaning that you know, be a little bit careful. See if the thing that you're saying or thinking of implementing is the thing that you're implementing, right? Like I said, like you could count the number of paths going from 0 to but also if you do it recursively, maybe it actually is the other way around, right? Maybe you actually want to kind of, you know, anyway, all that in mind. That's all. Let's see what's RNC. RNC is 100, so we should be okay with just like a little bit naive. And here, you know, and I'm gonna define it a little bit differently, right? So XY. So basically, this is the number of paths that goes from 0, 0 to XY, right? And you may notice that this is not quite the same as the number of paths that goes from xy to r minus 1 c minus 1. So you have to be really precise in which one you want to do, even from the get-go, right? Today, I'm just going to say let's do this one. And, yeah. So what are we doing? So basically, if x is 0, 0, and y is 0, 0, then we return 1, right? Because there's one path from 0, 0 to 0 to 0, 0, just by definition. Otherwise, yeah, so paths is equal to 0, and then we add it to count of x minus 1, y, and paths, because that's basically where it comes. These are the two possible paths, the previous path that it comes from, right? The number of paths from the left, or actually this is from up, and this. I mean, of course, and you have to be a little bit careful. So we have to make sure that, this is, and this is that. And that's pretty much it, really. You start from, or well, start from is a weird way to say it. So, you now then you just count from that, and you kind of, following what this function does, and you should be good. Is what I would say if you remember to take care of the obstacles, which we did not. I totally forgot about the obstacles, actually. What are these? I actually just totally forgot about the obstacles. What is this obstacles in? Oh, this is just a grid. For some reason, I thought it was like x, y, and then like some other factor. Okay, so yeah. Then it's even easier, right? So if obstacle grid of xy is equal to 1, I think, then we return 0 because there's no paths because you can't go through there. Let's try again, and this time less embarrassed and kind of good. Okay, so yeah, so I mean, if you've seen my videos, you know what I'm going to say next, which is we have to memorize, right? So x can go from 0 to r minus 1 inclusive. Y can go from 0 to c minus 1 inclusive, and each one we do all of one time if we memorize, so that sounds good. So let's do it. Right, and then that's pretty much it. Oh, what am I doing? Yeah, and then of course we should use it, so yeah. And now it is pretty much it. Hopefully I didn't make another, oh, huh. I guess so. I think this one I wasn't sure about, to be honest. Because like if you're already starting from there, that's why I was thinking about, did I make that mistake before? I guess not. I guess, I don't know. I mean, all it requires is us to change it to this. But I actually should have tested it, I suppose, because they actually tell you the answer. I forget. Because in a contest, they don't tell you the answer, but here they do. But yeah. Okay, fine. Yeah, that's all I have for this one. Let me know what you think. All times C time, all times C space. You could, again, use the space optimization trick if you did it bottoms up. And in fact, you can do it in all of min or comma C space. So yeah, I'm really hungry. So that's all I have. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.